Hello student, welcome back to lecture series on Fourier transform. So already I have explained what is meant by Fourier transform and some of the example in my previous lecture. All are the important examples I taught it here. Okay, so if you are interested to see this video, check in my playlist. In our today's video, I'm gonna explain to you all Fourier sine transformation, okay, which is the special type of the Fourier transformation. So there is also Fourier cosine transform, it is there, okay. So as we learn Fourier transform and also inverse Fourier transform, similarly we have in our Fourier sine transformation, Fourier sine transform and inverse Fourier sine transform, okay. So we are going to learn two results over here. Now see that guys, sine x or a sine, it is the odd function, okay. So sine is the odd function. Whenever it negative sign goes under odd function, it gives negative outside, okay. So sine, it is an odd function here. So if a sine is an odd function, then we are going to define sine only from 0 to plus infinity. Okay, so in our previous Fourier transform, what we have done, we defined Fourier transform from minus infinity to plus infinity. But sine, it is the odd function, and for only odd function we consider positive values, okay. That means 0 to infinity. If it is gives a negative value, sine odd function will give us the answer in the form of negatives, okay. So as we have sine odd function, so we only consider positive values here. Which value we consider for sine, okay. So Fourier transformation, okay, consider that x is the variable, okay. X is the variable. For that variable x, we are going to consider the value which only positive from 0 to infinity. Only these values we are going to consider for Fourier sine transformation, okay. Yes. Now see that guys, how can you identify in your exam that you have to apply Fourier sine transforms? Now see that whenever you get the interval, okay, like a 0 to infinity, then directly apply the results for Fourier sine transformation. Okay, so here let me write the definition for Fourier sine transform, okay. Fourier definition means I'm going to write directly the result that we are going to apply it for our example, okay. So Fourier it can be defined as Fourier can be defined as capital F, okay. So Fourier defined as the capital F. As we are going to define sine function, so we are going to take as a base yes, okay. Fourier sine base as a yes, okay, f of yes, and we are going to define over x, okay. Sorry, we are going to define over s, okay. Fourier we are going to define over s, and inverse it is going to define on x, okay. So Fourier sine transform, okay. So f of s of a capital S, it denoted as a Fourier sine transform and defined as 0 to infinity, integral over 0 to infinity, okay, integral over 0 to infinity f of x, okay. F of x is this one is our f of x is a inverse Fourier sine transform, okay. So this one is a small f of x sine sx, sine sx, sine sx dx. Now see that this one is the formula for Fourier sine transform, okay. F base of s of capital S, okay, 0 to infinity f of x sine sx dx, okay. This one is a Fourier sine transformation formula, very much important guys. So you will get the question based on this formula, okay. So try to remember, recite this formula, okay. Solve more example, you can easily remember it for longer, okay. Yes. Now if it is a Fourier sine transformation, it I defined here, so I also want inverse Fourier sine transformation, okay. So I want inverse Fourier sine transformation, okay. We want inverse Fourier sine transformation, as we have defined inverse Fourier transformation, okay. Inverse Fourier sine transformation, okay. We are taking for the sine, inverse Fourier sine transformation. So capital Fs of yes, it define Fourier sine transformation, okay. And small f of x, that small f of x it defined as, okay, small f of x defined as inverse Fourier sine transformation, and it written as f of x which is equal to 2 by pi integration, it remains same, okay, 0 to infinity, okay, integration it remains same, 0 to infinity. Fourier transformation Fs of capital S, okay, this Fourier sine transformation sine Sx ds, okay. Yes, as we are taking Fourier sine inverse, that means we have to take integration with respect to s ds, okay, and we are taking we are finding Fourier sine transformation, that means we are introducing f of x here, so that's why you have to integrate with respect to dx, okay. So remember these two things, okay. First, Fourier sine transformation, integrate with respect to dx, and inverse Fourier sine transformation, integrate with respect to dx, okay. So dx and ds here, okay. Yes, so which is a 2 by pi 0 to infinity Fs of capital S sine Sx ds, okay. So these are the two formulas are very much important here for finding the Fourier sine transformation and inverse Fourier sine transformation, okay. Make a note of these two formulas that we are going to apply for our subsequent examples, okay. Yes, so for there exists Fourier cosine transformation, it is also there, but we are going to learn Fourier cosine transformation in our next lecture. So for this is okay for our today's lecture, just the Fourier sine transformation, okay, as I want this video smaller. In our next lecture, we go for some of the examples which based on the Fourier sine transformation, okay. Some of the example based on the Fourier sine transformation we are going to learn in our next lecture. So that's it here for our today's lecture. You just have to remember these two formulas, okay. I hope you all have understood these two formulas, okay. So just need to remember this one for our next example. So thank you everyone, thank you for my today's lecture.